Hello students, today we are going to study about magnetization and magnetic field intensity. Magnetization, or also it can be said as intensity of magnetization. Okay, what is the intensity of magnetization? It is the ability of the material to get magnetized. It is the ability of the material to get magnetized, or also you can say the magnetic property of a particular material. Okay, so first of all we'll start with, we know everything is made up of matter. Matter is made up of atoms, and atoms are made up of orbital electrons. A single material will have hundreds and crores of atoms, and each atom will have some kind of electrons, or you can say there is a nucleus in the center. I have drawn a figure over here, a nucleus in the center, and there will be electrons orbiting around it. Okay, the electron will be moving around it, which means that charge is moving around the nucleus, which means that there is it will conduct the current. We know what is current. Current is nothing but the flow of charge per unit time, or rate of flow of charge. Means here the charge is moving, the electrons will be revolving around the nucleus, which means that they will behave as a current carrying loop. They will be behaving as a current carrying loop, and if they behave as a current carrying loop, then they will have a magnetic dipole, because it will have a magnetic north pole and magnetic south pole that we have studied in our previous lecture, which means that this will act as a magnetic dipole. Suppose M is our magnetic dipole. So each electron will have some magnetic dipole, each atom will have some magnetic dipole. So if in single material, okay, so matter which has crores of atoms inside it, okay, so each atom will have some magnetic moment around it. So if I draw it over here, you can see that this all are different magnetic directions, or you can say magnetic dipoles. All are randomly arranged. They are randomly arranged. So if we find out the net dipole moment, net magnetic dipole moment, then we can find out the intensity of that magnetic field. So what is intensity of magnetization, that is named by capital M, is given by net dipole moment of whole this substance divided by volume. That is what we do. We just find the net magnetic dipole moment for a unit volume, or you can say per volume. So this is our net magnetic dipole per unit volume. Okay, so which means that the more the magnetization, more the dipole moment, more will be the magnetization, which says that net magnetic dipole moment, if there is some net magnetic dipole moment, which means that it will conduct some kind of magnetic field, or it will have some magnetization. So the material inside it has some kind of magnetic field inside it. So here I have shown that the magnetic field inside the material is directly proportional to M, because what is M? M is our magnetization. If net magnetic dipole is more, then the magnetization will be more, which means if magnetization is more, the magnetic field will be more, which means that magnetic field inside the material is directly proportional to M, and that is, if we remove the proportionality, we have a constant, that is our permeability. Okay, if the material is in vacuum, then the constant will be mu0, that is permeability in vacuum. Okay, I hope this much is clear. This is nothing but the magnetization inside a conductor, or inside the material. Magnetization inside a material. If there is a material, what is the magnetization inside it? That is this. Suppose you have an iron rod, okay, so magnetization inside it is this. Okay, now this second part is magnetizing field intensity. What is magnetizing field intensity? It is the external magnetic field. Magnetizing field intensity means the electric field, or the magnetic field which magnetizes the material, which magnetizes any material. So for suppose we assume for a solenoid, if it is wounded and current is passing through it, it will behave as a magnet. We know the magnetic field of a solenoid is given by B is equals to mu0 Ni. Here the magnetic field depends on Ni. Okay, so we name this magnetizing field intensity as H, that is H equals to Ni. H equals to Ni, or you can also say H is number of turns in a solenoid, ampere turns in a solenoid to produce a required magnetic field. number of ampere turns in a solenoid required to produce given magnetic field. So here the magnetic field, instead of Ni I can write H, that is magnetizing field intensity. So B is equals to mu 0 H, and H will be equals to B upon mu 0. Okay, so this is how we can define a magnetic field or the magnetizing field intensity. This is the external field which will help us to make a material magnetized. Okay, so suppose here if we combine this both the things, if this material is kept inside a magnetizing field, suppose I have a solenoid which is producing a magnetic field. If I keep this material inside the magnetic field, what will happen? This all the dipoles will get aligned in one direction. All the dipoles will get aligned in this direction due to this external magnetic field, which means that after this all of these dipoles will be in single direction, though there may be some which do not follow this. So if you increase the intensity of this magnetic field, it will increase the intensity of the inside magnetic field also. Okay, the more the intensity of this, the more will be the intensity inside the material, which means that magnetic field inside the material or magnetization is directly proportional to the external magnetic field, or you can say magnetizing field intensity. Okay, so here we can take, I can write it in this manner. This is proportionality constant and it is known as magnetic susceptibility. I have written it over here. Means it is the ability of a material to magnetize itself under any external magnetic field. If I keep this material inside a magnetic field, that is external magnetic field, what will happen? It will try to magnetize itself. The more the intensity of this, the more will be the intensity of this, that is inside magnetic field. But there should be ability of the material also to align itself. If the material itself does not align itself, then there will be of no use. Means this zeta is magnetic susceptibility, that is the ability of the material to align itself or to get magnetized under external magnetic field. Now suppose if we take a solenoid, and if we put a material inside it. Suppose we take a solenoid and we put this material inside it. Then what will be the net magnetic field inside it? We'll write it by net magnetic field inside this coil. Okay, it will be due to both. It will be due to this magnetic field also, and it will be due to this magnetic field also. Okay, one is external magnetic field and also the internal magnetic. That will give you the net magnetic field. So I'll write it over here. Bm, that is magnetic field inside the material, and this B, which can be written as Bm is equals to mu 0 m plus, here we have B is equals to mu 0 h. Here you can say this is inside magnetic field, this is outside. So the net electric field will be due to inside and due to outside. Due to outside, that is external magnetic field, and due to internal magnetic field, that is inside the material. Okay, so I can write this as mu 0 m plus h. Okay, now from here I know the value of m is equal to zeta h, so I can use this also, is equals to mu 0 zeta h plus h. So if I take h common, I can write mu 0 1 plus zeta h. Okay, so I can write it in this form, but this 1 plus zeta is known as your relative magnetic permeability also. It is known as relative magnetic permeability also. So 1 plus zeta is equals to mu r. So if I put the value of mu r, I can write it mu 0 mu r into h. Okay, now you have studied previous also what is relative magnet permeability. Relative permeability will be equal to permeability of a medium upon permeability of vacuum. So from this I can write mu equals to mu 0 into mu r. I can write it in this form. So here I can write is equals to mu h, which is our final required thing. What does this say? This says that magnetic field intensity or magnetization field intensity depends directly on the medium. Here this is the net magnetic field. Okay, this is net magnetic field. H is magnetization intensity, which means the more the magnetization capability of the external field, more the magnetizing field intensity of external field will increase the magnetic field inside also. Okay, I hope this much is clear. Just I'll tell you these terms. First one, zeta, that we have already done, that is magnetic susceptibility. What is magnetic susceptibility? It is the ability of the material to magnetize itself under any external magnetic field. Second one is mu r, that is relative permeability. You know what is relative permeability? It is relation between the permeability of a particular medium to the permeability of vacuum. So here mu is permeability of a medium and mu 0 is permeability of vacuum. Okay, I hope this topic is very clear to you. Thank you students. Have a nice day. Keep studying. Thank you.